Necessity is the mother of invention, as the old saying goes. And it's fair to say that the need to explore the cosmos has required tremendous innovation. Oftentimes, outside-the-box thinking has played a critical role in solving problems for space ventures. American Space Agency, NASA, faced one such problem when it came to landing probes and rovers on Mars, and today's video focuses on the quirky solution they employed. However, as another saying goes, a solution is not quirky if it works. Humanity's fascination with Mars extends as far back as the days of Galileo, who first discovered the planet with his telescope in the early 17th century. However, we would have to wait 350 years before attempting to send man-made objects close to the red planet let to its surface. The Soviet Union, desperate to take the lead in the early days of the space race, would be the first to try, but this only resulted in a series of 5 launch and spacecraft failures from 1960 to 1962. The US would soon follow suit on the 5th of November 1964, but its Mariner 3 spacecraft failed to launch. However, NASA tried again 23 days later, and Marine 4 became the first man-made craft to complete a flyby of our neighbouring planet on the 15th of July 1965. America succeeded with 2 more flybys in the 60s, while the Soviets encountered 2 more failed flyby attempts and an orbiter launch failure. When the 1970s rolled around, the space race rivals were moving on to launching orbiters around Mars. NASA beat the Soviet space program to the punch yet again by being the first to launch an orbiter around Mars successfully. Buoyed by the success, NASA was ready to send a lander, and in 1976, Viking 1's orbiter and lander completed their respective missions. Another milestone the Soviets were yet to match. The lander touched down on Mars on the 20th of July 1976 and remained functional for 2,245 Mars days. This success was quickly followed up by the orbiter-lander duo of Viking 2, which was also a hit. The Viking 2 lander arrived about a month after its predecessor, lasting 1,281 days. The 2 landers relied on aeroshells, parachutes, and terminal descent engines to decelerate upon entry into Mars' atmosphere. They landed on 4 legs equipped with honeycomb shock absorbers. While the Viking 1 lander touched down fairly evenly, the second lander landed with one leg atop a small rock, which skewed its position by 8 degrees. Though NASA could still use and communicate with the landers effectively, it was very clear that luck had played a big role in the successful landings. The Martian terrain features endless seas of misshapen rocks, and these could easily have toppled the landers over to the side and compromised the mission. With these Martian missions demanding a ton of money and time, NASA chiefs knew they couldn't count on luck in future landings. Heavier and potentially pricier objects were in the pipeline for Mars, and the prospect of these missions being hindered by rocks on the ground wouldn't be a good look. Furthermore, the Soviets were still dogged in their attempts to one-up the US on Mars. By the end of 1996, NASA was ready to land on the Red Planet again on a mission called Mars Pathfinder. The Jet Propulsion Laboratory, JPL, which was a part of Caltech and headed by Tony Spear, was the group in charge of the mission and responsible for the upgrades to the landing gear. The JPL was also tasked with significantly reducing the costs of spacecraft and equipment, which it managed to do. The Viking program cost over $5 billion in today's money, whereas the Mars Pathfinder mission, which also included the Sojourner rover, was just over a tenth of that. This cost-cutting had everyone at NASA waiting with bated breath, as cheaper missions would justify more missions. The biggest change from the Viking missions was arguably the overall shape of the lander, which was now a tetrahedron. This shape change facilitated the removal of the previous lander's quadpod legs and shock absorbers. This time, Pathfinder would use 4 airbags, one for each of the lander's 4 faces. Each airbag was configured into 6 spheres to help maximize flexibility upon impact. The airbags would be tethered along the lander's 6 edges. Each face of these large inflatable balls was made of a special material called Vectron, which is chemically classified as a form of polyester. Vectron has a high tensile strength and is very resistant to abrasion. Each airbag had 4 layers of the material, with the inner layer being airtight to maintain inflation. The outer layers were increasingly less dense. The general idea was that by the time the lander touched down, it would be completely surrounded by a larger pyramid of inflated balls. The lander was launched from Cape Canaveral by a Delta II rocket on the morning of December 4, 1996. 7 months later, the lander entered the Martian atmosphere. The lander's aeroshell, one of the few remnants from the twin Viking landers, slowed the lander from 14,000 miles per hour to about 830 miles per hour. At this speed, the disc gap band parachute was deployed. At the same time, the lander's onboard computer was working with readings from the accelerometers to determine when to carry out the various descent functions. Once the parachute had reduced the Pathfinder's speed to 115 km/h, the computer ticked for 20 seconds before releasing the heat shield. A few moments later, the lander was lowered from the backshell using a 66-foot bridle. When the lander reached an altitude of 1,165 feet, onboard gas generators roared to life and filled the immense airbags with air in the blink of an eye. At 322 feet, the 3 retro rockets on the backshell fired up to help the lander fight Martian gravity. Finally, at an altitude of 71 feet, the Pathfinder's landing computer detached the bridle and separated the pyramid from its backshell, parachute, and descent rockets. Pathfinder's first contact with Mars was at 31 km/h in the somewhat flat Ares Vallis. As expected, the air-filled pyramid bounced and bounced and bounced, with limited accelerometer data indicating at least 15 bounces. The initial ricochet sent the lander to an altitude of more than 50 feet. The airbags held despite the tumbles and rolls, easily brushing off the unforgiving jagged edges of Martian rocks. Only when the lander came to a complete stop did the balls deflate. Winches on the lander reeled the Vectron sheets into a petal shape around the unharmed lander, which was ready to deploy the first ever rover to traverse Mars. The success of the Pathfinder mission was a landmark moment, marking the moment NASA and mankind had truly mastered the art of Martian landings. Inflatable airbags would feature again in 2003's Spirit and Opportunity rover missions. This time, there were 6 Vectron layers to protect the rovers. Again, the balls did their thing, and both rovers would go on to operate for thousands of days. Opportunity managed to roll around and conduct experiments for 5,351 Martian days. Despite their great success, airbag landings are now a thing of the past. This is mainly because of the sheer bulk of modern rovers and advancements in descent rocket technology. With that, we've come to the end of the video. Thanks again for watching, and go ahead and like the video. Subscribe to the channel and hit the bell icon to keep up with more awesome space venture videos. Take care.